Welcome to the course Mastering Algorithms, Analysis and Applications. This session is about calculation of time complexity. Analysis of an algorithm is broadly classified into two types. One is posteriori algorithm, other one is priori algorithm. So this posteriori algorithm is a relative analysis, whereas priori is an absolute analysis. Posteriori depends on the language of the compiler and the type of the hardware, but priori is independent of the language of the compiler and the type of the hardware. Posteriori gives an exact answer, whereas priori gives an approximate answer. Posteriori does not use asymptotic notation. We will be learning what asymptotic notations in the upcoming sessions. Whereas this priori uses asymptotic notation. Posteriori analysis differs from system to system because it is dependent on the hardware and dependent on the compiler, whereas priori analysis is same for every system. So knowing this, we will move on to the performance analysis. As already discussed, there are two criteria to analyze an algorithm. One is the space complexity, which is nothing but the memory utilized by an algorithm. Other one is time complexity, which is the time taken by an algorithm to run its execution. So this session we will learn how to find out the time complexity of an algorithm. To find the time complexity, we have a formula T of P is equal to C plus Tp. What is C? C is the compile time. It does not depend on the instant characteristics and it is done only once. Whereas Tp is the runtime. It depends on the particular problem instance characteristics and it is concerned and concentrated on the runtime. There are various methods to calculate the time complexity of an algorithm. Number one is experimental method. Number two, it is counter method. Number three, it is tabular method. So what is this experimental method? The value of Tp of n is found experimentally. That is, the program is typed, compiled and run on a particular machine, and the execution time is physically clocked. Means we are observing how much time it takes to compile and execute with a physical clock. Is this an efficient method to find out the time complexity? Every time we cannot hold the watch, see how much time it requires for compilation and execution. So it is not an efficient method. So we move on to counter and tabular method. So what do we do in counter method? Every step is counted here. So the program steps or the step count. It counts the number of executable steps. So if there are comment lines or declarative statements in your algorithm, then it takes 0 steps. If there is an assignment statement, then 1 step. If there is a conditional statement, then also 1 step. If there are loops, maybe for loop or while loop, then n plus 1 step. This n is for true condition and this 1 is for false. Anyhow, we will be checking the condition n times and at least once it will go false. So that is why for true it is n and for false it is 1. And the statements which are inside the body of the loop will be executed only when the loop condition is satisfied, that is true. So since this n is there, the same n will come here also. So that is why body of loop executes n steps. So let us see what are the steps involved in this counter method. Step number 1. We have to introduce a global variable called count. Step number 2. We will initialize that step variable as 0. And step 3. We will increment the value of this count variable for every executable step. So we will try solving a non-recursive algorithm and find out the time complexity. Here comes the example 1. here is an algorithm for swapping, and the solution is, in this algorithm there are 3 assignment statements. So before the steps are counted, we will introduce a global variable called count and assign it with the value 0. Then for every assignment statement we will increment. For this assignment statement, increment. For this assignment statement, increment. So you add all these. Sum of all these is 3. Since it is a constant, the time complexity will be order of 1. Example 2. Here is an algorithm in which an array is used. The size of an array is n, and for all the elements we need to assign the value 0. The time complexity. Initially we will declare a global variable count and assign a value 0. This is a declaration statement, so we are not incrementing the count. Then we have a loop. This loop will execute n plus 1 times. Why? Because n for true times, true statements, true conditions, and 1 for false. So this statement inside the loop will also execute n times, that is true times. So I am incrementing count for n times, that is true times, and for this assignment statement I am incrementing, that is inside the loop, therefore true times n, and finally this incrementation is for the false condition. So these two are inside the loop, therefore for true times it will be executed, that is nothing but n. So when I add all these, I will get 2n plus 1, and the complexity is in terms of n only, so it is order of n. To the next example, it is sum of elements in an array. Here is the solution. I will be declaring a global variable count and assign it a value 0. Here is an assignment statement, so count is incremented by 1. This is a loop statement, so it will execute n plus 1 time. So whatever statement which are there inside the loop will execute true times. True time is n here. So this for loop will execute n times. The statement will also execute n time, and this increment is for the false condition of the loop, so it will execute only once. And then there is a return statement. For that return statement also the count is incremented by 1. So if I add all these, it will be 2n plus 3. We need to express in terms of n, so the time complexity is order of n. We will move on to the next method, which is tabular method. So here the time complexity is determined by building a table, and the table gives you the total number of steps. The table actually contains 3 columns. The first column is number of steps per execution, which is denoted by S by E, steps per execution. And the second column will be number of times each statement is executed, which is named as frequency. And the last column is the total contribution of each statement, which is multiplication of column 1 and column 2. And the summation of this third column will give you the time complexity. Sum of third column will give you the time complexity. So here is the algorithm. So this is a statement. It is executed 0 times. So it is 0. Frequency is also 0. Product of these two is also 0. This float is an assignment statement. So this is an executable statement. So 1, it will be executed 1 times. So 1 into 1, 1. This is a for loop. It is an executable statement. So 1. And how many times will this be executed? N plus 1. N is for true times and 1 is for false execution. So that is why n plus 1, and product of these two will be here. And this is non-executable, so nothing. And this is an executable statement which will be executed only when the condition is true, that is n. So this is an executable statement, so 1, and it will be executed n times, so the product is here. And the return statement, this is also an executable statement. It will be executed once. The product of these two is here. So summation of all these, that is 2n plus 3 will be the complexity, but we will represent in terms of n only. So it is order of n. Next example. This is for addition of matrices. So this statement is just simply a function declaration. So it is not executable. Frequency is also 0. And here is an executable statement. So 1. This will be executed m plus 1 times. M is true times and 1 is for false condition. So multiplication of these two will be here. And this is another loop which is inside this outer loop. So this inner loop will execute n times plus 1. N times plus 1. But this loop will execute if and only if the outer loop is true. So the outer loop, if it is true, will execute for m times. That is why here I am including m into n plus 1. So this n plus 1 is for the inner loop, and this inner loop will execute for true times of the outer loop. True times is nothing but m. So that is why I am writing m into n plus 1. So the product of these two will be the total steps, that is m1 plus m. And this statement is an inner statement of my inner loop. So inner loop, true times will be mn and false times will be m. So mn denotes true and m denotes false. So the statement, inner statement Cij is an inner statement of the inner loop. So true times of the inner loop will be the frequency of this statement. So that is why this m1 comes here. So multiplication of these two, it gives mn. So summation of all these will be 2mn plus 2m plus 1. So I have to take the highest degree of n. So here only mn comes, n comes. So this portion will not be considered while calculating my time complexity. So it is order of mn. The third example is for matrix multiplication. So this is not executable, frequency 0. This is executable. This will execute for n times, and for one statement it goes false. So it is n plus 1. This is inner loop and this is my outer loop. So inner loop will execute n plus 1 time if and only if the outer loop is true. So true part of outer loop is n. That is why it is n into n plus 1 here. And this is the inner statement of this loop. So this will execute only if this part is true. So true part of this is n square. So that is why here I have written n square. And this is another inner loop. So this inner loop will execute if and only if this loop is true. So that is why the true statement which will execute n square time is taken here. So for this loop alone it is n plus 1, but that will be executed if and only if this is true. So this true part is n square into n plus 1. So when I multiply, I will get n cube plus n square. And this is the statement which is inside this loop. So whenever this loop is true, this statement will execute it. The true part is given by n cube. So that is why this statement is executed n cube time. So multiplication of these two will be n cube. So summation of all these will be 2n cube plus 3n square plus 2n plus 1. We need to take the higher degree of n, and that is why it is order of n cube. And here is some important points for loops while identifying the time complexity. Whenever you have a for loop of this form or the reverse form, it will execute n times true. The statements will execute if and only if the conditions are true. So the frequency of this for loop is n. And whenever you have a statement like this where I starts with 1 and I is less than n, and every time I is incremented by 2, then the number of times the statement inside the for loop will be executed is n by 2. If it is I plus 100, it will be 100 by 2. If it is I plus 50, it will be 50 by 2. And whenever you have a for loop of this type, it starts with I is 1, I less than n, and I is incremented by multiplying by 2 or by dividing by 2. In that case, the statements inside the for loop will be executed log n times. And if there are two loops like this statement will be executed n square times. So true times of this one and true times of this one. So that is why it is n square. Hope you understood how to calculate the time complexity of an algorithm.